to Associate Professor Dr. Samuel Moveh, our Honorable Speaker, Post Lecturer Dr. Shamsatun and Dr. Afrikah, and all 8123 students. Welcome to the Global Learning for Mathematical Geometry entitled Application of Geometry in the Real World, organized by Post Lecturer of Foundation of Geometry, University Technology Mara, Johor. So I am Nur Azina, your moderator for today's session. Actually, we are very lucky to have a sharing session with an experienced speaker from the engineering faculty, which will expose the student to the application of geometry in the real life and to switch the student's perspective about learning and point of view about learning mathematics. I hope all the goal tips and knowledge will be shared by our speaker can enhance our passion toward this course and widen our view about mathematics. All participants are welcome to raise the question in the chat box. Without further delay, we will start our sharing session on application of geometry in the real world. Before that, allow me to introduce our speaker. Dr. Samuel Moveh is an associate professor from Aeronautical Engineering, Faculty of Engineering and Architecture, Istanbul Gelişim University, Istanbul, Turkey. Since 2022, he received a bachelor degree in engineering from Modibo Adama University, Yola, Nigeria. Master degree in engineering from Ahmadu Bello University, Zaria, Nigeria, and a Doctor of Philosophy in Mechanical Engineering from University Technology Malaysia, Johor. He was awarded with a doctoral degree by UTM on 2021. Previously, he has experience as a research assistant with the Infinite FM Sdn Bhd, in which he involved in strategic planning with the country Garden Pacific View for development of smart city and high-tech digital hub. Besides, he has a keen interest in journal publication. Currently, he has succeeded in publishing a total of 22 publications. Last but not least, he has held several positions during his study as a vice president, secretary, and a member in a student committee. Without further delay, please welcome Dr. Samuel.
Thank you so much. Good morning to everyone, or good afternoon. Let's say morning from my end and good afternoon from Malaysia. First of all, I want to thank everyone. I want to thank UITM for this very rare privilege. I am indeed grateful. And also I want to thank the coordinators of this lecture also. It is actually an honor for me to be here. Like I always tell people, Malaysia is dear to me. Malaysia is a second home. Malaysia has always been my second home. And I look forward to coming back to Malaysia someday. So without further ado, let me just give a brief history. Just like Dr. Azlina has said, I did my doctorate.
I
Sorry?
need a slide. Your slide.
Oh, my. Okay. Can you see my slide now?
Yes.
Okay. So just as Dr. Azlina has said, I did my doctorate in Malaysia, and I spent a couple of years in Malaysia before I moved to Istanbul, Turkey, where I served as the Erasmus coordinator and also the vice head of department for aeronautics engineering department from 2022 to date. Just recently, I also moved to Riga, Latvia as an associate professor. So I I am basically holding two positions, but in the near future, basically, I will hold one. So for now, my main affiliation is Riga, Latvia, which is Transport and Telecom Institute in Europe, where I serve as an associate professor in the robotics department and faculty of engineering. So without wasting your time, let's start today's lecture. Now, today's class basically it's about applications of geometry in real world. Now, a lot of us as kids, as we grew up, we understand or we have heard in one way or the other what geometry is. When you hear the word geometry, what comes to your mind basically is shapes, planes and figures. As kids, we grow up learning how to identify different shapes. We start by identifying lines, circles, squares, and rectangles. Okay. And as we progress in life, as we grew up to become adults, we now realize that geometry could actually be applicable in our daily lives. Or basically, geometry is what makes the world simpler and easier. So, to understand that fact, we are going to go through some basic key points. Now, in our lectures today, we are going to talk about what we are expected to learn at the end of this lecture. I tag them the learning outcomes. So for every student here, at the end of this class, you should have some basic understanding of what we are talking about. Then also we are going to introduce what geometry is and talk about some brief history. We have a lot of founders of geometry. In fact, a lot of cities, a lot of countries where geometry was developed simultaneously in the past. Then we ask ourselves why we need to study geometry. Then we also look at some key types of geometry and some examples that we probably have seen. We'll talk about some axioms and some Euclidean geometry. Then we go straight into the main application of geometry itself. Okay. Now, to start off, understanding geometry or the application of geometry in real world, it extends beyond practical knowledge or theoretical knowledge. Sorry, theoretical knowledge. It goes beyond theoretical down to practical knowledge. So you don't just stay in class to study geometry. The knowledge of geometry can be applied in practical terms. So you don't just learn it in class, you can apply it in doing some practical items. So at the end of this class or this lecture, I said, we will understand that we could use the basic principles of geometry to do certain designs or to understand certain patterns, okay, in certain fields. Now, one of the learning outcomes is practical problem solving skills. Now, at the end of it, students will be able to apply geometric principles to solve real world problems, you know. And when you solve real world problems, you are creating solutions to problems. Also, at the end of this, you have the ability to understand what we call critical thinking. You'll be able to apply critical thinking skills using the application of geometry. Because when you want to apply geometry, often it requires critical thinking skills. So, as students, you want to analyze a situation, you want to identify a particular problem or identify a particular pattern, then you need to understand that geometry could give you that kind of result. Also, at the end of this, it will enhance what we call spatial visualization. Okay. Now, when you work in real world, the application of geometry enhances your ability to visualize and manipulate objects from 2 dimension or from 1 dimension to 2 dimension down to 3 dimension, especially those in engineering. As an engineer, when you want to design and you have a model and you want to do your 3D design, you have to understand that before you get to your 3D design, you have to do your 2D design or your plan. And from that basic principle, you now understand how to draw from 1D to 2D down to 3D. Also, learning geometry also is also an interdisciplinary field because the beauty with geometry, it cuts across every field. You understand? It's not just only mathematics. You use the principles of geometry in mathematics to solve engineering problems, to solve medical problems, to solve agricultural problems, to solve geographical problems. So it cuts across interdisciplinary connections. So students may recognize and appreciate the interdisciplinary nature of geometry. So understanding how it connects to various fields such as physics, engineering, computer science, and architecture. Then also effective communication. Now, when you want to apply geometry in any real world context, often it involves communication of solutions and ideas. If I call you now to design something for me, so it involves you communicating your ideas to me. So as engineers or as architects, if you want to share your knowledge or your idea with me, you have to use the basic principles of, or you have to apply geometry in one way or the other. These are standard practice. Architects share their ideas in sketches. Engineers express their ideas in terms of designs and as well. So when you're doing all this, you have to apply the use of geometry. Also in terms of technology integration, where we have to integrate various kind of technologies together. So many real-world applications of geometry involves the use of technologies such as computer-aided design softwares. Now, computer-aided design softwares are softwares that we use to translate our ideas into fertility. You understand? As an engineer or as an architect, if you want to express your or communicate your design, you can use softwares like computer aided design software. We have so many of them. We have AutoCADs, we have SolidWorks, you know, we have multi-sim. There's so many designs there. In electrical engineering, when you need to design circuitries, design logic gate systems, you can use multi-sims. You understand? You can run simulations also with all this. And all these processes involve the use of geometry. Then also we appreciate that when you have a real world application, often it demands precision. So if you are designing, let's say, a component of a car, or you're designing a building, for instance, you should know that precision is utmostly important. Now, you cannot just pick your pen and your paper and just draw a sketch and expect us to produce based on your sketch. No, we have to make detailed calculations. We have to take detailed measurements. We need to know the length of the building. We need to know the breadth of the building, the height of the building. You need to know the whole landscape measurement and all that. And when it comes to all these things, we have to work with precision. So precision is super important. There is no room for error when it comes to measurement. So geometry is applied in trying to achieve this goal. Then also in our careers, you understand, career readiness. I term this career readiness because understanding how geometry is applied in real world prepares you as a student or a career in any field. You understand? Some of you at the end of the day might end up becoming engineers, architects, planners, what we call them, geosurveyors, geoinformacy engineers, or even medical doctors as well in the field of medicine. So your understanding of basic geometry will help you facilitate or help you perform better. In other words, help you interpret patterns, designs when it comes to your chosen field of career or your chosen field of profession. Then also we have another one called ethical consideration. Now, in some applications, students may explore ethical consideration related to geometric decisions, such as land use planning and environmental design. So you see, you cannot talk about how you want to use a particular space or how you want to plan a particular environment without considering geometry. You understand? It's super important. In fact, both of them go hand in hand because when you want to manage a confined space or an open space, you want to plan it well, then you need to understand the basic concept of geometry. Then we have basic project-based learning opportunities. Now, in this case, lecturers like us can design projects that requires students to apply geometry in designing real-world situation. Now, I could have like a simple project where I want to design, let's say, a 3D a 3D model of mechanical components, or let's say a simple component. Now, in order for you to design that 3D component, you need to understand what we call 2D drawing, perspective drawing, projections, line projections. In engineering, we call it orthographic projection. We call it oblique projection, first angle projection, third angle projections, where you have to draw lines. You understand? So you need to understand the basics of lines and geometry to be able to carry out that project. You cannot just pick a project and just go ahead and design a simple 3D. Whatever software you use, the application of circles and lines and squares are what we use to produce a 3D model. There, of course, we have the cultural and the historical content. Student may explore the historical content or explore the historical and cultural aspect of geometrical applications, understanding how geometry has influenced architecture, art, and even scientific discovery through history. Now, in the course of this lecture, we are going to see how geometry evolved during its early days to where we are today. But before we get there, I'll give you a simple example. Today, we have artificial intelligence, we have facial recognition. Now, a lot of you use this stuff on your mobile phones. Even some people use it in the shopping mall. When you're going to the shopping mall, there's a device or a camera that, or in the airport itself. Now, one of the basic principles in designing a simple uh, algorithm or a simple software for facial recognition is how to capture the face. And in order for us to capture the human face, we need to specify certain grid lines. Okay. That is why sometimes when you look at videos online or look at any image processing video you see or facial recognition video, when you put your phone or your face or you focus to the camera, you see a box capturing your face. So you can see that we have evolved from when we started applying geometry to a more sophisticated era where we could make devices, we could use cameras and image processing or computer vision techniques to apply geometry to capture our faces. And not just that, that same technology could apply also in other aspects. Then also we have the environmental awareness. Now, application of geometries in areas like environmental planning, sustainability can foster an awareness of the impact of geometry decision has on an environment. All right. So, introduction. Now, at the end of this lesson, I said we should have basic understanding of those outcomes which I just stated. So, geometry, as we know it, is often thought of as an abstract of mathematics or a concept in mathematics, and it plays a very, very crucial role, of course, in our everyday lives, which is very true. So today we will explore geometry and how it is applied in various fields and various industries, and also learn how we can use geometry to shape our world. But before we can do that, we need to understand some basic concepts. We need to understand the evolution of geometry. Who started geometry? How did geometry come into play? You understand? If we say that geometry can help uh, treat or create our modern world, then the question is, where did geometry start from? So geometry has a long and rich history. Believe me, it has so many history. When you read about geometry online, you learn so many things. Now, this history spans from several cultures and basically civilization. And also, geometry was found as a result of uh, several cultures and several civilizations, several cultures trying to, you know, to solve problems, which has fostered what we call civilization today. So the development of geometry can be traced back in ancient times, and it emerged independently in various parts of the world. Now, at a point in history, geometry was evolving in various continents or in various parts of the world. So before the Common Era, that's 3,000 years before the Common Era, in ancient Egypt. Now, geometry was often associated with ancient Egypt because it was used and developed for practical purpose. They used it for land surveying and also construction. So ancient Egyptians used geometry to measure you understand, and redistribute land, you understand, after an annual flooding of the Nile River. Now, most people believe that the Nile River is one of the longest river in the world, but arguably it's been argued recently in various researches online. But in Africa, that we can agree that the Nile River is the longest river in Africa. So the Egyptian, their quest of planning or their environment or constructing or looking for a way to, to plan their land after certain floods had occurred, created geometry. Also in the ancient Mesopotamian eras, where particularly the Babylonians, okay, they also made significant contribution in geometry. They also developed mathematical techniques, used for measuring areas and volumes. Today we have areas of a square, we have areas of a rectangle, we have areas of triangles, and areas of square. And believe me, you see, the area of a square, the area of a triangle, and the area of a circle, these simple things that you learn now play very, very important roles in sophisticated designs that you know today. I'll take a simple example. When you go to the design of aircraft or designs of robots today, it could be an industrial robot, it could be an educational robot, whatever kind of robot. Now, as long as it involves shapes and it involves a 3D model and it involves design, at one point or the other, we are going to consider the area or the volume or the size. In other words, the size of a particular. So during the Babylonian era, they created and they developed these mathematical techniques and they used to measure all this stuff. Then also the ancient Greece, the ancient Greeks. Now, the ancient Greeks also are often credited for formalizing and synthesizing what we know as the formal geometry today. If you look at some books today, they will tell you that geometry was actually formed by the Greeks. In fact, they will tell you that it is a branch of engineering where, or a branch of mathematics, which was created by a Greek mathematician, okay, in a work he wrote called Elements. You understand? Now, his name was Euclid, a Greek mathematician who wrote Elements, a comprehensive compilation of mathematical knowledge at that time. Now, Elements is a fundamental work of geometry, or has always been a fundamental work of geometry, and covers topics such as plane geometry, numbers theories, and also solid geometry. These are different aspects of geometry. Now, the term geometry is wide. Believe me, if we want to continue to talk about geometry, we'll talk about it for days and for days and days because it finds practical application in every spheres of life. But today we are just going to narrow it to a particular aspect. So in India as well, ancient India, also an Indian mathematician, including scholars, made a significant contribution in geometry. You understand? They developed what we call advanced trigonometry concept and calculated the value of pi that we know today. 2 pi. You understand? In all our calculations, when we want to calculate the area of a circle, we use pi. So they helped in developing this, and they also express geometric principles in the context of astronomy. Today we find astronauts, people going to space, people going to another universe or going to another planet. Now, you cannot plan on going to another planet without taking geometry into consideration. In fact, from the transport itself, from the aircraft or the spacecraft down to the final destination, geometry plays a very, very significant and important role. Then also the Islamic Golden Age also. During the Islamic Golden Age, scholars in the Islamic world translated and preserved the Greek and the Roman mathematical texts. Now, mathematicians made further advancements in geometry and algebra. Today we have algebra. We use algebra in so many aspects. And it was. Then we also have the European era, okay, which we call the Renaissance of the European era. Now, they saw a revival of the interest of classical interest of the classical Greek and the Roman knowledge. So mathematicians built, upon ancient geometric ideas. They took the whole ideas of the Greek, of the Romans, and they built on it and they improved on what had been in existence, incorporating algebraic method and introducing what we call the coordinate system today in geometry. Now, when you want to go into navigational systems, you want to go into engineering designs, you want to go into robotics, you will know that algebra and coordinate system or coordinate geometry plays a very, very important role. You cannot rule them out completely. Now, when you peruse or you go through history, you realize that geometry has evolved as a very, very practical tool for solving real world problems, including, just to mention a few, land measurement, architecture, astronomy, navigations for pilots, for UAVs, for astronauts, and for even you as a student. When you drive your car, you use Waze, you use Google Map. Now, geometry has helped evolve. You understand? It has served and it is still serving as a practical tool in which we use to solve this problem. Many years ago, it was difficult for us to go from point A point to point B without even knowing where we are going to. But today, we can easily map out from point A to point B with the help of geometry. Okay, so its development was shaped by the need of different cultures and civilization. Now, you need to understand that as a human race, there is constant need for evolution, there is constant need for change, which is why we as academicians and as researchers, we always try to solve problems on a daily basis. We are going to continue this trend for as long as we are alive, because as long as there is life, there's always going to be a problem to solve. And it has been proven time over time that one of the best ways to solve current problems is through the application of mathematical principles. And one of those mathematical principles is geometry, in terms of design, in terms of planning, in terms of development, in various aspects. So you see, mathematics play a very, very crucial role. And it plays a crucial role in advancing not just this mathematical knowledge, but also in understanding scientific methods, scientific ways of designing, scientific approach of carrying out experiments. Now, today, geometry continues to be one of the most important and fundamental branch in mathematics, with applications in, believe me, in almost, I was telling a friend of mine, geometry is applicable in all fields, believe me, in lots of fields, even not directly, but indirectly. Okay. All right. So now the question now is, what then is geometry? If we say that geometry is so important to the human development or to the evolution of civilization, what then is geometry? A lot of people have heard geometry. Most people don't understand what geometry is. Okay, so geometry was derived from a Greek word geo, which stands for earth. Then, of course, we have metron, measure. Okay, now if you remember the Egyptians, they used it for surveying and for planning after the flood. Now, you can relate the surveying, planning with earth and measurement. Now, it is a branch of mathematics that deals with the properties of measurement and relationships of points, lines, angles, and surfaces and solids. So we are going to go deep and see what points are, what are lines, what are surfaces, what are angles, and what are solid. If we say that geometry deals with the measurement of all this stuff, then what are this stuff? What is a point? What then is a line? And how important is a point in civilization? How important is a line in civilization? Now, where can we apply points? Where can we apply lines? Where can we apply angles? Where can we apply surfaces and solids in terms of the growth or the evolution of science or the evolution of civilization itself? So, in order to answer that question, then we need to understand why we need to study geometry. So, if you say that geometry is the study of points, line, then why do you need to study geometry? If it's the study of points, how important are these lines? And how important are points? How important are solids? And how important are all this stuff? So, why do we need to study it? Why do I waste my time to study geometry? Why can't I just go straight and read engineering without understanding the basic principle of geometry? Why can't I go and read architecture? Why do I need to understand the basic principles of geometry? Why can't I just go and read medicine? You know, become a physiotherapist, therapist, or work in the radiology department or the X-ray department? Why can't I just go and learn those things? Why do I need to understand the word geometry? The answer to your question is without the basic principles of geometry. Of course, you can study, but you will not understand. You will not be able to interpret as an engineer what designs are. You will not be able to carry out design as an engineer. As a medical doctor, you will not be able to interpret X-ray scans. Okay, so there are so many of them. As a geographer, or as you cannot be able to interpret maps. When you're faced with a situation where you have a map before you, you need to, let's say we have a missing person or a missing aircraft, and you have a map before you, you have the region of which that person went missing or where the aircraft went missing, you cannot successfully locate that person. Now, it's not new thing. A lot of us here have watched so many movies. We've watched so many movies where at one point in any of the movies we've watched, we realized there was a plane that got missing, and you see one of the ways in which they track the last known whereabout of that plane is bringing out a map and putting a meter rule, taking coordinate systems on the map. Now, you see, that process is easy when you understand the foundation of geometry. Okay. So, now, in our workplace, why do we need to study geometry in our workplace? Now, many different scientific and technological fields require knowledge of geometry, especially in more advanced specialized studies like the use of geometry in various fields, like as airport officials, where you work at, let's say you work at the control tower, or you are, let's say, a ranger who is managing a particular park, wildlife park. You need to understand every nooks and crannies of the park. So you have a map. You need to study that map. You need to understand that part. So as an engineer, you have a problem that is before you. How do you solve that problem? How do you translate your ideas? Okay, you are faced with a task to design a simple robot. How do you translate your design on paper? How do you make us understand it? You have to apply the knowledge of geometry. So it's very important to do that. Now, also, another thing you need to understand is geometry gives you the ability to make use of your entirety of your brain. So you can use the full capacity of your brain. How? It enables your creativity, enables you to think well. Now, geometry helps you to bring together both sides of your brain. In other words, not just one part, the left side thinkers, but also the right brain thinkers. So you bring both sides together and you function well to bring out solution for a particular problem. Now, the left brain is the more logical, technical field, whereas the right brain is the part of visualization. So you have one part that is involved in technicalities or thinking. You have the other part that helps you visualize whatever you're thinking. So imagine synergizing both of them together. It makes your abilities to perform better. Now, geometry can help you do that. Then also, by doing that, it is enhancing your creativity. You understand? Now, think of genius that created man, made wonders. They all made the use of geometry. If you think of any scientist today who propounded any law, any simple, you understand, they all use the concept or they use geometry in one way or the other. You see, today as robotic engineers, as design engineers or control engineers, whenever we want to make a design, the first thing we need to do is get what we call a mathematical model. We need to look for a mathematical principle or mathematical theorem that explains our scenario for us. So by so doing, we are playing with geometrical terms. So you see, this is one of the reasons why you need to study geometry. So if you have any future to become a robotics engineer, an architect, or to be a medical doctor, or to be, let's say, an astronaut, you need the basic knowledge of geometries, because in some aspects you will use numbers, in some aspects you will use lines, in some aspects you're going to consider shapes. So the interrelationship of all this is the applicability of geometry. So you see, that's very important when it comes to that. Now, in 3D thinking, you have your 1D design, you have your 2D design, you have your 3D design. Now, in your one-dimensional design, you just have a single line. But that line can be used to create a shape. Now, you want to solve a problem without the knowledge of geometry. It's going to be difficult because you don't know how to place the lines correctly. But with the right knowledge of geometry, you can take a line and try to solve your problem. Let's say the shape you want to design a box where you can put in your devices inside your box, or you want to create a car, or you want to create an airplane. Now you have the concept of lines. From lines, you can create shapes. Now, the long tube of an aircraft is called a fuselage. Now, the fuselage looks like the shape of an egg. Then when you look at the wings of an aircraft, it looks like a shape of a triangle made of lines. So with your understanding of how to convert one dimension to two dimension down to three dimension, you will be able to create your design from the scratch, from your head. When you think well, you can use any 3D design software or even use a sketch with your hand to design using lines and shapes to design whatever you want to design. So 3D thinking, the study of geometry, is very important when it comes to 3D thinking. That is why we need to study geometry. Two and three dimensional shapes originated from geometry. Basically, that's just the point. Every three-dimensional shape, every two-dimensional shape originated from geometry, originated from lines. So you cannot escape it. So the use of triangles and other shape has strongly influenced, and I will even say is still influential till this day, the use of 2D and 3D design in diverse applications. Another application is architecture. This is a very, very common application. You have a big structure, it has a length, it has a width. You before you even build a structure, you have to do your planning, you have your landscaping. Now, from your planning, from your floor plan to your elevation to all those designs, you now bring out your 3D design. Now your building looks very good and very beautiful. Now, if you look at it, it all became beautiful as a result of the applications of simple lines and simple shapes. Today in the construction industry, you find what we call there's what we call BIM, where you can build actually a structure now without even using bricks. You use what we call precast. So you want to build a big story building. This is practically practiced in most developed societies. In Malaysia, in Singapore, they do this a lot, where they bring a big column and they assemble them together. So it makes construction super easy. And also we have what we call the preparation. Now, geometry is good. It's a good training ground for students to make use of concrete materials activities. Okay. Now, those same experiment now will become stepping stone later in life. Now, you have shapes. We have what we call in what we call most of you know what we call Legos. In robotics, we have robotics for kids under the curriculum we call STEM education. where we bring kids and we teach them science, engineering, and technology. So we use shapes to teach kids. Now, the reason why we do that in STEM is because at a very young age, we're trying to put in the knowledge of building stuff. We're trying to teach these kids that it's possible to build a house or a robot or a car using different shapes and different objects. Then you take some electronic components and you put in it and you do your programming and your program works. So by doing all this, it prepares you as a student for a well chosen career, for your career ahead. Like I said, most of you might end up becoming programmers, might end up becoming engineers, architects, mathematicians, even politicians, believe me. You might think that politicians don't need geometry. They do when it comes to budgeting, when it comes to budgeting. They want to look at the landscape of Johor Bahru and they want to compare it with Malacca. They will say, oh, no, no, Johor Bahru is so big. So we should budget a large amount of money. In Malacca, it's not that big. So we should budget less money. So you see, it cuts across every field. So adequate preparation of the knowledge of geometry is also important. This is one of the reasons why we study geometry. Then also geometry widens your horizon. It makes you believe that, look, I can think outside the box. If I don't understand geometry, if I don't study geometry, my thinking is shallow. I am not vast. I'm not critical when it comes to solving problems. I get confused when I have a problem before me. I get agitated. I get scared. I cannot do that. I cannot do this. But when you have the knowledge of geometry, you understand what planes are, what surfaces are, what areas are, what lines are, line segments, and all this stuff. You know, you will be able to solve problems and profile a solution. Say, oh, I think if we apply a line from point A to point B, and we take the line from point B to point C, or we take the line from C to D, then we can map out this region easily. So you see, you are thinking outside the box. Your creativity will increase. So by applying geometry, you learn to think outside that box. Now, the same solution can be applied to many other areas of your life, not just academic. Sometimes you want to go to, let's say, you are in Johor Bahru, and you're in CIQ, city center, and you want to go to, what you call it? Let's say you want to go to Nelai or you want to go to Pulai, and you want to go to the normal straight highway, or you want to go through Austin, Mount Austin, or you want to go through what you call it, Pulai Indah. No, sorry, you want to go through Pulai Indah, or you want to go through Bukit Indah. Now, your ability to map out the region because you have driven your car or you have passed through this route will now help you to do a decisive calculation and say, oh, this will be my fastest route. If I go straight from City Square, passing through Danga Bay, I will get to Pulai or Kulai in time. But if I go through Bukit Indah, I might encounter some traffic. It might take time. If I go through Mount Austin through the other side, it might take time. Okay, so you see, the knowledge of geometry even helps you plan your own life. At some point, you're not even aware of that. Now, how can it do that for you? By giving you the ability to think critically. Why? Because your understanding has improved. You have a vast understanding. So when you learn to use geometry, you also learn how to think logically. Now, this is very important in everyday life, like I said, as not everything is easy and understandable. Sometimes you are forced with a particular situation. Oh, I need to do this. I need to do that. I need to be here. I need to be at point A. I need to be at point B. I need to be at point C, all within 2-3 hours. How can you achieve that? Now, by understanding the basic principles of geometry, sometimes we do it consciously, sometimes we do it subconsciously. We don't even know. But by doing that, we are applying the basics and principles of geometry. So when we are thinking logically, many difficult problems can be erased and can be solved easily, and simple solutions can be found. So you see, that's the advantage of learning geometry because it helps you break down critical problems into simple solutions. And as a result, you have plenty options. Before, you never had any options. You were, oh, how can I solve this problem? But now you can solve the problem because you have so many options. Okay. Now, to reason logically is one thing that you definitely must learn whenever you study geometry. So you study geometry, whatever kind of geometry you study, whatever type of geometry you study, it will give you that ability to reason logically and to be able to understand the wonders of the world, shape, and everything around it. We need to be able to understand the knowledge of spatial use. Now, in other words, the areas related to space and position. You see, space, location, position, size, shape, these are key things that play a very essential role in geometry because these are the key components that shaping our society today. You might ask space, how? Simple. You are a town planner or you are an architect and you want to do a plan. You need geometry. You're looking for a particular location to set up a business or to set up an industry. You have a map that's before you. You don't know how to interpret that map. You need geometry. You want to know the size of somewhere. You need to measure it. Since we say geometry deals with the properties of measurement, of points, lines, and all that, you need geometry. And how you want your building to look like. You want to have a very big story building, a high-rise building, or a simple bungalow, you need geometry. So you see, you cannot escape it. You understand? You just cannot escape it. And one very important thing you need to understand is if you want to manage space, you want to manage or find out the size, or you want to plan very well, there are two major components that are super important. Numbers, because when you make measurements, there is a figure, and that figure is a number. It could be a real number, it could be an ordinary number, whatever kind of number it is. So you see, when we know how to apply and understand the relationship between shapes and sizes, we'll better be prepared to use them in our everyday lives. Now, geometry will assist us in doing that because it provides knowledge on how to deal with measurements and relationship of lines, angles, surfaces, and solids. I have different lines crossing each other. I want to create a simple planning. I want to plan one region in Malaysia or in Johor Bahru. I don't want intersections. I don't want roads. I want to have only three intersections at three different points. One intersection at point A, one at point B, one at point C only. I don't want to have intersections within the town. So proper planning, proper measurements, proper understanding of lines and angles will help us understand this. You want to build a high-rise building, put an elevator, but you also need to put a staircase where people who don't want to use the elevator can use the staircase. Then also you need to make sure that you design your staircase properly at the right angle. Okay, so you need the knowledge of geometry. Then also we have our visual abilities. Now, some people think okay, some people believe that when they want to solve a problem, the only way they can solve that problem is by visualizing different shapes. There are some people like that. When you give them a problem, they try to visualize those problems in a shape format. They try to see how they can solve it. So some people think in shapes and in sizes. Others will think with visual abilities. So you see, as individuals, we have different ways in which we can visualize things, which we can see things. When I look at my laptop now, what I see is a rectangle. For some persons, when he look at my laptop, what he sees, it's a white background. Now, when another person look at my laptop, what he sees is lines. So we have different ways and different abilities at which we can visualize stuff. So when we study geometry, it helps enhance that ability. So that when we are visualizing, we need to understand, we need to have the basic understanding of geometry to be able to do that. So you see, your imagination is like an untapped source of object that all needs to come together in one particular set. So you have so many things in your head, you cannot place it. So many shapes, numbers going up. But with your understanding of geometry, you can easily tell, oh, this is a square, this is a line from point A to B. This is why you can look at a problem and simplify the problem. All right. Then we'll talk about since we understand that why it is important to study geometry. Then let's look at what are the major common types of geometry that we know. Like I said, geometry is very wide. Now remember, the goal of today's class basically is to learn or to realize that geometry can be applied in our everyday life, or the application of geometry, can be applied in our world which we live in today, or is applied in the world which we live in today, and is still being used on a daily, and is to still be used even in the future. But we have different kinds of geometries. So whatever thing you are designing, or whatever you are thinking, whatever problem you're trying to solve, the understanding of different kinds of geometry will let you know what geometry I need to understand. If I am, let's say, a radiologist, for instance, or I'm a medical doctor, or I'm a physiotherapist, and I work with x-rays, now I need to understand the basic concept of lines and shapes, so that I can understand and interpret images. In engineering and in robotics, we call it image processing. We call it computer vision, where you have a video or you have a picture and you process it. And you process it, by processing, what we mean is you bring out useful information from that picture. So when you have your x-ray, you bring out information out of your x-ray. So the ability for you to do that is your detailed understanding of lines and shapes and patterns, which is very important. So there are different kinds of geometry based on whatever problem you are trying to solve. You choose the right one. So we'll just talk about briefly some of the major types that are commonly used out there. Now, this is a word that you have seen, Euclidean geometry. Of course, it's from the Greek, Euclid. Okay. Now, this is a traditional geometry and was developed just by the Greek. Now, it is based on a set of statements called axioms, and it's concerned with different properties. Okay. What are those properties? Flat surfaces and solid in a particular Euclidean space. So we have the Euclidean geometry, we have the non-Euclidean geometry. Now, for the non-Euclidean geometry, now they do not adhere to any parallel postulates or parallel axiom or any statement leading to a different set of geometric principles. Now, a typical example of this particular kind of geometry is what we call the hyperbolic geometry. Now, in this geometry, parallel lines diverge and angles of a triangle add up to less than 180 degrees. So when you have a design that you need this particular principle, then you use hyperbolic geometry. Now, this particular design geometry is used in so many fields. So depending on what you're trying to solve, if you have a detailed knowledge of hyperbolic geometry, it will help you simplify the hurdles or the problems which you're trying to solve. Then we have the elliptical geometry. Here, there are no partial parallel lines, and the angles of the triangles add up to more than 180 degrees. So if your design will entail an angle that requires more than 180 degrees, then you have to apply the concept of elliptic geometry. Also, we have other geometries like the analytic geometry, the differential geometry, the projective geometry, and the topology geometry. Now, what is the analytic geometry? When can you apply the analytic geometry? Now, it's the type of geometry that is basically uses algebraic techniques, your basic algebra. Now to study this, any form of generic shapes or points represented using coordinates. Okay, and equations are used to describe this particular object. So if you are trying to design a time in space or an object in a particular space in a particular system, you're trying to design that and you're trying to develop your mathematical model, then you can apply this analytic geometry. where you take the basic concept of algebra. You understand? Then you have your shapes and you have your points, you have your coordinate system, the XYZ coordinate system, and you carry out your analysis. Then we have the differential geometry. Now, this field involves the study of curves, surfaces, and manifold using techniques from calculus and differential equation. Now, it has application in physics and particularly in general relativity, not just in that, also in engineering, in control design, in robotics design. You see, in robotics and in control systems engineering, when we want to design a system, when we want to run a simulation of a system, we take the mathematical model of that system as a differential equation. And from that differential equation, we convert it to what we call a Laplace transform equation. Then we further go into what we call a transfer function or a state space model. Then we begin to put in our parameters. Then we run our design. Now, for instance, this is a car. Let's say this is a car. I want to design this car. I need to set up a differential equation. So in this case, I'll use differential geometry. Based on the principle of the working principle of a car, now I'll create a differential equation, convert it to my transfer function or my state space model. Then I begin to put in my parameters in my simulation software. Then I run my simulations. I can only run my simulations if I have my differential equation. Now, simulations are, mimic of our actual system. You want to design a car, you take the parameters, or you want to build a building, you take the parameters of that building or that car, and you run a computer simulation. You test it at various parameters. If it holds, then you take that new parameters that you have used to simulate and produce this system. Now, projective geometry. Projective geometry deals with the properties that are invariant under projective transformation. It extends to the concept of points also when we're dealing with points, lines, and planes by introducing an idea of points at infinity. Then also we have topography. Let me remove this. We have what we call topography. While not traditionally considered as part of geometry, now topology study properties of space that remains unchanged. Now, the word topography means, the nature of a space of an environment. Now, the topography of Istanbul is hilly. So, in case any of you is planning to come to Istanbul during the summer, you have to prepare because sometimes to work from point A to point B might take you up to 10 to 15 minutes or even 30 minutes, no matter how short it is. Why? Because the topography of Istanbul is hilly. So you have to put on your sneakers and you have to walk. So in some way, some people might say topography doesn't relate to geometry, but in many cases it is. Because if we say to the study of space and the pattern on the area, how it looks like, then of course, some countries have flat grounds. In Malaysia, there is flat ground. In Istanbul, there is high grounds. So we have a trajectory of hill, but in Malaysia, we have a flat surface. And we says that planes and flat surfaces properties are what we study when it comes to geometry. Then we have what we call the discrete geometry. Now, the discrete geometry is a branch that deals with discrete set points, often in the combinational or computational context. Its application in computer graphics, computer-aided design, and of course, algorithm. Now, in engineering or in robotic system, we have what we call the discrete system. We have the continuous system. Okay. Now, in continuous system, we don't have much options. Discrete systems, it's basically digital. It's basically yes or no, true or false. Okay. So we cannot take we cannot make assumptions. Now, in simulations or in designs, when you design, using computer-aided design softwares, let's say like AutoCAD, like SolidWorks, you don't make assumptions. When you want to design the design and draw your model, you don't make assumptions. You draw with details. When you're building your computer code, your algorithms, you don't build your computer code with assumptions. Okay, you build with actual figures. You use what we call looping system, the if else statement or the for while loop. But in that case, you are still specific with your, if it's this, then execute. If it's not this, don't execute. If it's this, then do this. While it is waiting, do this. These are simple computer programs. So in discrete geometry, these are where we apply them when we are creating computer graphics, video games, and all that stuff. We apply discrete geometry. Then we have the algebraic geometry. Now, this basically deals with algebra, study of solution of polynomial equations and their generic interpretations. You know polynomials. These are very, very common geometry. Then we'll have the last one, which is a type of geometry that extends to differential geometry to space where a matrix is defined, allowing us to study what we call curves and shape. And also, this is basically applied when it comes to robotics and engineering. Now, these are just some few examples. You should know that we have various kinds of geometry. Like I said, if we want to keep studying the various kind of geometry now, it will take us ages. So these are just some very common one, all classified and arranged in various subsets for you to study. And if you want to have better understanding of any one of them, like discrete geometry and how you can apply it in computer designs or computer programming, then you can dive in and expand your horizon. You see, now you're hungry. You understand that, oh, I could learn discrete geometry and I could be very good when it comes to programming. I could become very good when it comes to graphics design. So you're hungry for more knowledge, so you dive in. But you should be aware that there are several other specialized branches and interdisciplinary areas of geometries as well, not just this particular one. So each type, but one thing you need to understand is each type of this geometry provides a unique insight into the properties and relations of objects in different mathematical and real world concepts. So you have a problem that you want to solve. Now you want to use the principles of mathematics to solve this particular problem. Or you're looking for a way to make life easier in terms of shopping, in terms today, if you look at it, e-commerce is taking over. You can sit at your home and make online purchases. You can make a business. You can even run a business using e-commerce. So we have specialized platforms. Some people use Amazon. Some people use in Malaysia. I think they use Lazada. They use what you call it? I've forgotten Shopee and all that. Now, when you look at the back end of the algorithm that was created, it involved the principles of geometry because people are buying stuff from different parts of the world on a particular problem platform. Not different platform, it's the same platform, but the only difference is geographical location. So in your back end design, you need to put that into consideration, the knowledge of geography. And when you want to put the knowledge of geography, it means you're going to learn the knowledge of mapping. And to understand the knowledge of mapping, you need to understand the knowledge of planning, lines, shapes. You understand? So these are the things that you should put behind your mind whenever you have a problem to solve. How can I use mathematics to relate this particular situation now and solve this problem? All right. So now let's pick just one, the Euclidean geometry, and see how we can apply it and see some of the examples of Euclidean geometry. Now, of course, since we said that Euclidean geometry is a classical form of geometry and was developed by the ancient Greeks, now it is based on a set of statements called axioms, including the famous parallel postulate, and deals with flat surfaces and objects in three-dimensional spaces. Now, what is an axiom, you might ask? Now, an axiom sometimes could be called a postulate. Now, it's a mathematical statement that is regarded as a self-evident or an accepted statement without proof. Now, it should be so simple that it is obvious and unquestionably true. So your statement that should be accepted or your action should be as simple as possible and it should be true. We don't need any extra thing to do any extra thing to make it true. For instance, I have one point here, I have another point here. If I say this is a point, this is a point, my statement is true. I don't need you don't need any explain to any other analysis to know that it is true. If I say this is a line that cuts across point A and point B, it is true. You don't need any scientific analysis or any lab work to understand that this is true. So an axiom forms the foundation. These statements they form the foundations of mathematics and can be used to prove others more complex results. So if we say these actions are the fundamentals, like lines, line segment, angles, and all that, these are examples. They are the fundamentals when we need to prove other complex results, which is true. You understand? Now, so Euclidean geometry is basically used in traditional mathematics education and has practical application in so many fields. But one of the common, very common fields that we use it a lot is architecture and design. Now, design cuts across every field. Design could be for engineers, design could be for architects, design could be for the craftsmen as well. Design could even be for the fashion designer, the interior designer. Okay. Design could also be for the X-ray designer, the machine, the person who manufactures the X-ray design and all that stuff. So, Euclidean geometry, sometimes called parabolic geometry, is the geometry that follows a set of prepositions that are based on 5 postulates. Now, what are those postulates? They are based on 5 actions, 5 statements. What are those statements? The first statement, it says that it is possible to draw a straight line segment joining 2 points. That is true. You have point A, you have point B. So it is possible to draw a line to join point A and point B. We don't need any scientific proof to, to agree to that. Anyone who says he needs a scientific proof to agree that uh, we can draw a line from point A to point B, then that person has a problem when it comes to understanding or creativity. Another one, it is possible to indefinitely extend any straight line segment continuously in a straight line. This is a straight line. We can extend it indefinitely. We could stop anywhere we want, but we could continue to extend it. We don't need anything to prove, any extra proof to prove the statement. Now, we have a given straight line segment. It is also possible to draw a circle, having the segment as the radius. So you have a circle, you have a straight line. We could draw a circle around that straight line, and that straight line could end up being our radius of that circle from the center of that circle. Now, also, all right angles are equal to each other or they are congruent. Now, through a given point, not on a given straight line, only one line can be drawn parallel to a given line. We're going to see that example as we progress downwards. So we'll see if this postulate or if these statements are true. Now, the most basic term of geometry, like we said, are points, lines, and planes. So the question now, or the reason why we're having this class basically is how can we use points? How can a line or how can a plane be applicable in a real life situation? The answer is points, line, and planes are very, very applicable. In fact, they play a crucial role in our survival, in our existence today. Now, a point has no dimension. It's just a point. Point A, point B, point C. It has no dimension, nor does it have a length or a width, but it definitely has a location. So we could say point A is at Malacca, point B is at Johor Bahru. So we can see that we have location for our point, but there is no direction. Direction or length or dimension doesn't play any role. But if we want to create a map or create an application, something that we will use, then we can relate both points together. So you see, we're now applying geometrical terms, keywords, points to create a path. Now, a line, on the other hand, is a straight and extends indefinitely until it stops. Of course, in the opposite direction. And a plane is a flat surface that extends also indefinitely. So let's look at some of these examples. Now, when you look at this uh, example, you have how many points here? We have 1, 2, 3, 4, 5 points. So a point, one of the points, let's say a point A is a specific location in space, describes the position of that particular point. Like we said, it has no shape nor size themselves. It has a specific location in that particular space. So point A could be at Malacca or it could be at Johor Bahru. Then a line also is a set of infinitely many points that extends forever in both directions. So if you look at this, with lines are always straight and just like points, they don't take up any space. They have no width. So when we look at this, our lines here are labeled as A and B. That's the green color, and of course our purple color there. So we can also refer to them using 2 points lines. Okay, that's, you could draw, let's say, PQ with a bar with 2 arrowheads on top as a line. That's how we represent them mathematically. Then we have what we call a line segment. Now, a line segment, but before we go to the line segment, now, you see, when you are mapping out, you're trying to map out points in surveying or in architecture, in anything, you can use the point system to map it out. Now you have mapped it out, you begin to draw your lines. You draw your line, okay, I want to have a triangular system, or you are using your computer to draw any design. You have your point A, point B, point C on your coordinate system. You're trying to draw, let's say, cylindrical item or a square or a rectangular item. Of course, you have 4 points, 2, 3, 4. Then you use your computer aided design to join all the points together with a line. So you join A, B, C, D, and you have your rectangle. This is how it's applied when it comes to computer design. So a line segment is a part of a line between 2 points, okay, without extending to infinity. So it starts from one point and ends on the other point. It doesn't extend to infinity. Then a circle, of course, you know what a circle is. A circle has a point in the center with a line that extends from that point to the circumference of that circle. Now, this is what we call the circumference of the circle. The entire size of the circle is called the circumference of the circle. So our point is here, and our line is from that point to the circumference, and it's called our radius. Now we have also what we call a ray, which is part of a line, but it starts at a point and extends infinitely in one direction. Now you see the difference between the ray and the line segment. The line segment starts from one point and ends at another point. So you want to design a railway system from Johor Bahru to Malacca. You cannot use a line segment. You can use line segments at intervals. But if you want to extend your rail system from one interval to another, then you use a ray. So the train track is designed from Johor Bahru to Malacca. It starts from Johor Bahru to Malacca. You have your first line segment of the rail track. Let's say you have first 100 meters, and you want it to extend beyond 100 meters. So after the 100-meter, you now extend another ray, and it goes like that. So you have several extension line segments that extends. Okay. Now we have studied different types of geometry. We have seen why it is important to study geometry. We have also seen what we are expected to learn at the end of this course, or the understanding we're supposed to have at the end of this particular lecture of what geometry is. But how can all this knowledge be applied? The question is, how can we bring all this knowledge of lines, knowledge of points, knowledge of angles, flat surfaces, and planes? how can we bring them together? How can we use them to enhance our creativity? How can we improve on our critical thinking? How can we, spatially design uh, or manage a spatial space? If we visualize a space, and how can we put all this knowledge together? Now, learning geometry gives us a lot of basic skills and helps. In fact, while you're learning geometry now, for you, some students, some of you might agree with me, you just don't care about it. You just want to pass. Some people just want to pass, have an A or a B and C. But one thing you fail to realize is subconsciously or consciously, so some of you, you are putting in the basic foundation of what will shape your future. Because in 2 years' time, in 1 year time, in 3 or 4 years or 5 years, you will fall back to these basic principles. So that's what we mean that learning geometry gives us a lot of basic skills. It helps us develop our logical thinking skills, critical thinking, analytical thinking, and of course, enables us to solve problems. That's one. Geometry also, as a concept, allows we, the learners, you understand, to link classroom objects in our classrooms, to real world situations. And we can relate it and approach it in a design perspective or in an interpretational perspective. And at the end of the day, it helps us bring out realistic thinking or realistic designs or make realistic ideas or bring out some crazy, beautiful ideas in terms of design, especially for those who are going to study architecture and all that, because you're going to use all this a lot. Also, understanding interpersonal relationship is important in area of problem solving and critical thinking. You want to solve a problem, you need to see how they relate. You want to solve a problem, there's a flood. You understand? Okay, I think Malaysia has suffered a lot of flood in recent times. So you want to solve that problem. It has to do with planning. What is the location you want to solve that problem? What's the geometric location? What's the length? What's the width of that location? Is it a plain surface? Is it a topographical? How is the topography of the area? Is it a hilly place? Is it a swampy place? Is it a rocky place? You understand? So you need to relate the environment itself, the location of the environment, the size of the environment. You relate all these properties so you can solve the flooding problems. You understand? It's not just digging drainages and all that stuff. No. Even if you dig drainages, you need to apply geometry in digging your drainages because you are going to dig them to a certain depth. And of course, it has to be to a certain length. So that's line. So you still have to take this into consideration. Now, also, it finds great application in real world application as it helps us decide whatever material to use, which design to make, and what plays a key role in our construction process. Like I said, you're trying to solve the flooding problem. Now you have the location. You want to build a drainage system. Now you want to dig the drainage. You have options. You could either use bricks and build the drainage, or you could use what we call precast. Now, the shape of those casts is very important. Shape is geometry. What kind of shape? Should we make the drainage in the form of to be parallel, to be like a rectangle or square, or we should make it in a V shape? We should taper one edge and make it wider at the top and slimmer at the edge. If you observe, most of our drainage systems are in the shape of a V. It has a tapered edge below and a wide edge before. It is for a reason. You understand? So the shape of the casting itself is super important. The kind of material we're going to use is also important. In addition, during the early stage of development of basic every human being, there's no human being that didn't pass through this. We all did pass through this at the early stage of our development as kids. Now, at the point we learned from geometrical shapes and sizes, using different toys. Some of us had toy cars, some of us had toy dolls, some of us had toy bricks, Lego bricks, and all that stuff. So these help improve what we call our cognitive development. That's our ability to recognize, oh, this is not square, this is oval. Oh, this is a rectangle. Oh, yeah. Oh, this is a square. You understand? This is a triangle. So that cognitive ability of every child, you understand, was developed using geometrical shapes. So now let's look deep and see all these attributes of geometry. How is it applied in real world? In the real world today. When we look at our environment, when we look, do we see anything that relates to geometry? Yes, we do. So let's look into some basic examples of geometry that plays a vital role in our day-to-day lives. The first one is nature. You know, the beauty of Malaysia is when you look, you see greeneries, you see trees everywhere, different kind of trees, tall trees, short trees, beautiful flowers. You know, you see them. Now, the most common genetic pattern in existence are mostly seen in the environment around us. If we look closely, we find geometric shapes and totally different patterns of flowers. Now, all these flowers and all these leaves, they all have different shapes. Now, they have different shape for a particular reason, depending on what kind of flower it is. And their shape gives us certain information that we need to learn. So if we want to study more about this plants or the environment around us, the plants and the trees and nature around us, we will be able to interpret the pattern and the shapes. Now we can use what we call computer programming, image processing techniques, computer vision, to process these images, and we could get vital information that will help us even improve the growth of this plant. Today we have what we call um, botanical gardens. We have gardens where we plant some of all these flowers and these trees. We also have greenhouses where we nurture all these plants. Now, the knowledge of managing a greenhouse or a botanical garden came out from understanding the various shapes of this plant and their purpose. And of course, you know how important the plant is in our daily lives. You understand how humans and plants are related. What we breathe in, they give to us. What we breathe out, they use. And we need the sun, they also need the sun. Some of you must have heard of the word photosynthesis, where the plant gets its nutrient from the sun. So you see, there is that interrelationship between humans and plants. So if we look closely, we can find geometric shapes, totally different patterns and flowers, leaves, roots, and all that. And the leaves of these trees comes in various sizes and various shape. Now, another very, very important one that we use every day, you understand, is in mapping. We fly planes from Asia to Africa, from Africa to Asia, from Asia to the Americas, from Asia to Europe, and we don't understand that there is basic geometry that plays. The pilot who is flying the plane is reliant on his navigational system, and the navigational system is heavily designed on the principles of geometry. So geometry helps us in accurate calculation of the physical distance. That is why it is easy for us to fly from point A to point B, because our navigational system had been designed with that precision. Remember earlier when we said when it comes to the application of geometry, we must use precision. Precision plays a key role. We said that earlier. So imagine if we didn't take precision into consideration. It will be very difficult for us to fly from point A to point B. But these days we can fly point A to point B. We even have options. We can go the longest route, we can go the shortest route. When the weather is bad, we can avoid the weather. You understand? And all this was as a result of geometry. So geometry plays an accurate role in calculation of the physical distance. It also employed in the field of astronomy to map out distance between stars. So we know the distance between different stars. This is the sun, this is Venus, this is the planet, and this is Earth. So we know the angle that Venus and the sun has to planet Earth. We can estimate all these things through trigonometry, through geometry. So this is very, very important. It also aids in the determination of the relationship between movement of different bodies within space. Recently, uh, we had space exploration where some tourists flew to the space. So how they move in the celestial world, in the space, in that environment, geometry plays a typical role. In fact, mathematics is the key for the success of that trip. That trip, from the engineering aspect, from the design of the spacecraft to the design of the space shuttle, down to even the entry into the space environment, everything was based on mathematical, accurate mathematical calculation. So far, as many of you who want to be astronauts, and many of you who wants to be aircraft pilots, as many of you who want to be aircraft maintenance engineers, or how many of you want to work in the aviation industry, then you need to study geometry. It is very, very important. You understand? Then also we have designers. If you want to be a 3D designer, you want to be a designer when it comes to architectural design, engineering design, whatever kind of design that involves the use of a computer aided design software like AutoCAD, SolidWorks, Multisim, different kind of softwares out there, then you need to understand the principles of lines and planes. You see, in engineering, there is what we call introduction to line drawing. The first year of every engineering student in every university globally, they need to study what we call introduction to technical drawing. It is the foundation of engineering drawing. And one of the course that is subject that is taught to them is how to draw lines. We have different kind of lines. How to draw shapes. You might think it's simple. I remember there was a time I was teaching my first year students, sometimes last year, about lines, and they were laughing that it's so easy. I said, yes, it's easy because it looks like child's play. But these are the things you are going to use when you want to design complex shapes. You cannot design a complex shape without understanding what a line is or knowing how to draw a line or know how to draw a curve or how to draw an angle. So you need to learn all those stuff. So geometry, one of the principal concepts of mathematics, entails lines, curves, shapes, and angles. So before any architectural design is done, or any engineering design, or any computer software programmer, say designer, you need to help in rendering any visual image or on any screen. You need to learn this. So rendering any shape, drawing any device, planning or making any beautiful 3D architectural drawing uses geometry, uses lines. So lines help us draw and render our shapes. Then also in our construction. Now, in your design, you use lines to render those shapes to make your building looks very beautiful. Now, the time of the actual construction now comes where you have to make the construction. You have to build your building. You need to understand that also geometry is important, not just in the design aspect, also in the construction itself. So before construction, any architectural form, mathematics and geometry helps you put forth the structural blueprint. So you have the blueprint, which is your design, your sketch, your plan, that's your blueprint. That's geometry, lines, shapes, and all that. Now, the theories of proportions and symmetries shape the fixed aspect of all kinds of architectural design. So we have Pythagoras, the principles of harmony, along with geometry, were all employed in architectural design during the 6th century. Now, if you look at this picture, this is a simple stairwell. You might look, oh, it's very easy, but no, it's not easy. If you look at it, there are angles here, every line. And some of these angles make an angle of 90 degrees, 90 degrees. So you see, we need high precision. If any of this angle is not 90 degrees, then there's a problem. It's no longer a stairwell. It becomes hazardous, it becomes dangerous. So you see, in not just the physical, not just in the engineering design or in the concept stage, also in the production stage. In the production stage, we need to also involve precision. In the manufacturing sector, where you manufacture products, mass production in the industry, geometry plays an important role from the design even down to the production itself. On the assembly line, there's a symmetry at which things work. On the conveyor itself, you're assembling one component to another component. It follows a straight line, it follows a particular pattern, and it follows a particular shape. So you see, geometry is not just important in design, it's also important in the actual production itself. Then one of the most common and the most common one that we use every day, our mobile phones, our computers, our television, the internet, is the example of geometry that we see in our everyday life is in technology. You see, we play with geometry every day. One of the first things we need to do as robotics engineers, as computer programmers, as coders, in whatever engineering or technological aspect we're working on, is we need to understand what is the geometry. You see, in English, when you hear what is the geometry of this shape, or what is the geometry of your design, what that means in English is what is the structure of your design. And when you talk about structure, you're talking about shape, you're talking about pattern. Is your design a flat design? Is it a solid design? Is it a hollow design? So you see, these are things that must be considered at the early stage of your design. So the most common example of geometry in our everyday life is technology. Now, be it whatever in robotics or in computer or video games, geometry is applied to all of this underlying concept. Now, the computer programmers are able to work because of the concept of geometry at their disposal. You use numbers, you use coordinate systems. If this is this, if X is this, then let this be this. Okay, there should be an increment from this to that. You play with numbers. Now, one of a very popular thing that we see, ray casting. What is ray casting? It is the process of shooting or that employs a 2D map for simulating a 3D world. Now, most of you have played computer games. You've played games like NBA. You've played games like soccer. You played games like God of War and all that games. You know, Need for Speed and all that. Especially soccer and football. If you see how those games, you see Ronaldo, you see Kobe Bryant, you begin to wonder that the game actually simulates the real style of the real player. How is it done? It's done by raycasting, where you see the athlete is fixed with some gadget lines and some sensors connected to the computer, and the simulation is done. We get the complete action of his moves, then we implement it in our design. This is a very popular thing in the gaming industry. Then, of course, for many people, a lot of people will not even know this, but even in X-ray, in ultrasound, in MRIs, one of the popular things is even in ultrasound for pregnant women. You see, pregnant women go to the hospital to check their babies. What are they going to check? They are going to check to see the formation of the baby. Is the baby growing well? Is there a breach in the tummy? You carry out an MRI. They go through your brain to see what's going on in your brain. An X-ray. Some people have a hole in their chest. Now, we don't understand how it happens, but the only way we can see it is through an X-ray. And how we can know it is through shapes and sizes. So this is very, very important in the medical industry. Geometry is applied in the medical industry every day. Some of us have gone to the hospital, have experienced one or two of this, but we don't even understand that it was geometry in play. So techniques like X-ray, ultrasound, MRIs, you understand, and nuclear imaging requires a reconstruction of shapes, organs, and bones, and sometimes tumors in the case of cancer. You understand? When we want to see how large or how small the tumor is for a cancer patient, we use an MRI, we check it. Even during surgery, when the tumor has been removed, you still have to go and carry out another test so we can see to be sure that there is no longer tumor in that place. And this is made possible through reconstruction, through geometry. So we see in the physiotherapy industry, they employ geometry. In the geometric properties and features, they help us define the image of any digital grid. So you see, the geometrical concept not only aid in visualization, it doesn't help us to see only, no. It also helps us manipulate. You understand? Sometimes in the medical industry, we have what we call uh, computer vision, application of computer vision in surgery, where you see surgeons carrying out a surgery looking at a screen and they're trying to take out a tumor. Sometimes when you're trying to take out some growths or some tumors, they are not reachable from a typical normal surgery. So they have to employ other means, use a camera device to go and see the angle it has. You understand? Basically, you create a coordinate system inside. If you look at this image, you have A, B, C, you have your axis, same thing here. You have your axis, A, B, C. So you want to take something around A here, and you're coming from C. So with the ability of what you call it, geometry, you can easily go through A, get what you want, and understand what you want to do there, and you're out. So you see, geometry helps. In fact, geometry is the future of the medical industry relies on geometry, AI, and also computer vision, image processing. These are the three future of the medical industry because these three things will help make our surgery easier or will help solve a lot of medical problems for us in future. Then the most popular one, the most common one, another common one that we see at we use for entertainment is sports. We have football, basketball, volleyball. Now, geometry is used to design the pitch itself. The football field is geometry. The geometrical shape of a football field is in the shape of a rectangle. One half, another half. That's why during the game we have what we call the half, the offside. So even during play, geometry is applied. A player should not be found within the half of his opponent alone with a ball trying to score. It's called offside in soccer. Okay. In basketball, you're not supposed to stay in the bucket for more than 3 seconds. The bucket is under the rim. There is a round line under the rim. We call that a bucket in the basketball. You're not supposed to stay there for more than 3 seconds in basketball. That is why if you observe any basketball game, you see they pass the ball very fast. Within 3 seconds, they throw the ball to the net because it's against them. So they use geometry. You see the go round. Then also in cricket, in baseball, the angle at which you take a swipe, in golf, the angle at which you swipe is very important. It's important. You swipe well at a good angle, then the direction of your ball goes towards a particular line or a particular pattern. So this is often important. Sport often does not fail as a sole chance to make use of geometrical concept. The building of the sports stadium itself, the athletic field, they take into consideration geometric shapes. Even the athletic field and also employs geometry, hockey, stair, and football, and all that. Even in the rules, they use them. Then, of course, we are not going to rule out art. You understand? Art is very important. You see, even though art was made with painting, with hands and brushes and paint, you believe me, it was done from high precision and high understanding of the fundamentals of lines and shapes. So you see, art encompasses the formation of figures and shapes, a basic understanding of 2D and 3D designs. So this is very, very important. So the formation of shapes is a result of the use of geometrical forms like circles, triangles, squares. Now I'll tell you, if you look at this picture very well, you see the lines. This is the fundamental principle we use in developing what we call facial recognition softwares today. We use geometry to capture the face. We use geometry to capture the license plate of every car. Now, if you go to developed cities today, you have speed cam. In Malaysia, between Johor Bahru and Kuala Lumpur, there are speed cams where if you pass a certain speed. Now, these cameras use geometry to estimate the plate number, the, the angle at which they capture the plate, the license plate of the car. That's geometry. Then even the code, the information being sent also is geometry. So you see, it's not just in painting, also, even in digital painting, in digital designs, or digital work of art, we also use the concept. Now, this is also another form of art or design. Now, this could be our beautiful architectural design. We could have even our interior designs. We can use geometry. Geometry is widely applied in the field of designing. We can create animated figures in video games and even in real life. Now, in the case of art, almost every element of design is adwin with geometrical proportions. You cannot just pick and just draw. No, you have to do, oh, what am I drawing? I need to draw a face. So I could start with a curve or start with a line or within the surface, or rectangle. So you see, it plays a very, very crucial role when it comes to designing anything, not just work of art, designing in engineering sector, designing in aerospace industry, in the medical field, even in agriculture. So you see, it plays a very, very important role. So in summary, the application of geometry is in real world. It cuts across every field. It's not just mathematics. Rather, it is the application of mathematics in solving real life situations in every aspect. What aspect? In architecture, in engineering, in sciences, in environmental sciences, in arts, in agriculture, in sports, in every sphere of life. So the application of mathematics or the principles of mathematics in solving this problem gives rise to the application of geometry. So it is a versatile principle, and it not just contributes to innovation, it also helps us grow, it also helps precision, and most importantly, it creates a problem solving skill for us, not just in our field, but in every aspect. When you have a problem solving skill, it makes geometry an integral part of the nervous
Sorry
professional
to interrupt.
domain. Okay,
Actually,
so
the
thank you so
slide
much.
is not moved.
Hello?
Sorry to interrupt, Dr. Samuel,
Yeah.
but I think the slide did not move. It just freeze.
Okay, where are you now?
Now I can see. Thank you.
All right,
But
thank you. But were you able to hear me?
yes,
Okay, so thank you so much. We have come to the conclusion of our class. Any questions? Hello? Any questions?
Dr. Samuel, are you done with your presentation?
Yes, thank you.
Okay, now we have arrived to the question and answer session. So to all the participants, you may type your question in the chat box, or you can ask directly by unmute your audio. If there is any question.
Dr. Samuel, I have a question.
Okay, sorry, can you introduce yourself?
Okay, my name is Adam Taufik. I have two questions.
Okay.
If I want to further my study in the geometry area,
Yeah.
what is your advice for our for students like us? Second question, beside basic geometry and other geometry knowledge, what else or what other related subjects do I need to learn? Okay, that's all for me. Thank you, Dr. Samuel.
Okay, thank you so much. Now, to answer your first question, you said if you want to study geometry. Now, studying geometry is for a particular reason. Why do you want to study geometry? And you understand, you cannot just study geometry. You need to study geometry in application of a particular field. So, if I ask you, your strong suit, are you very good in engineering sciences, or what are you good at? Computer science. Are you there?
Yes, Doctor.
So,
Uh,
what do you have strong? What is your strong suit? Are you a good computer programmer, or are you good in science and engineering?
uh, my course usually science and mathematics.
That's good. So now you see, you need to, if you want to study science and mathematics, like I said, geometry is wide. It has a wide aspect. You need to specify what area do you want to be very good at. What part of geometrical aspect do you want to be good? Do you want to be good in differential geometry? Do you want to be good in the Euclidean geometry or in the non-Euclidean geometry? Now, you need to understand that whatever knowledge you learned there is going to help you solve any problem. It's not any, but most of the problems that you might encounter. Like I said, in engineering, we fall back to mathematics. In medicine, we fall back to mathematics. So if I have a problem now, I need to solve. And you are very good in, let's say, in differential geometry. You are very good in it. And I have a model I want to make. I can easily work with you. I will tell you this is what I want to do. I want to create a mathematical model. Can you help me design this differential equation that I'm going to use to run my simulation for my system? I don't know. Does it make sense?
For me, I already understand.
Okay. Yeah, I can hear you.
Sorry, Dr. Samuel.
Yeah, I can hear you. Sorry, I want to charge my laptop. I can hear you. So your second question was what? Hello?
Oh, okay. My second question, beside basic geometry and other geometry knowledge, what else or what other related subjects do I need to learn?
Design, engineering design, design principles, basic design analysis. With your knowledge of geometry and your design principles, your basic knowledge of design, you will be able to improve in any field. If you want to work with an architect, you can work with an architect. If you want to work with an engineer, you can work with an engineer. You understand? So you need to learn and improve. You need to learn how to interpret basic design. You have an idea. How can you break your idea into simple bits and pieces, and you can use it? So you can work with design engineers. Okay. Any other questions? Hello?
I think there is no more questions from students.
So can I ask my own question?
Yes, you can ask the students.
Yeah. Guys, can I ask my question?
Can sir.
Okay, okay. So how many of you here have interest in being computer programmers? Or how many of you here? Now, how many of you play computer games? A lot of you play computer games, right?
Yes. Yes, Doctor.
So what's the most popular game you play?
PUBG, sir.
Valorant.
Grand Theft Auto.
Valorant.
That's good. So, do you know that geometry was used in designing those games?
Yes.
Now, most of you love. How many of you love C. Ronaldo or Messi?
Yes, yes.
Yes.
Aha. So in PS5, you remember the up, down, the moves that you make on your pad, where you get your game pad and you make the beautiful CR7 and Lionel Messi
Yes,
moves.
yes.
Now you see those moves where we were able to translate those moves directly from Messi and from C. Ronaldo into the graphic scene through geometry. Because when you look at, yes, okay, when you look at it, when you look at the pattern at which they play football, you see that they go in circles, lines, they go. So that pattern using ray casting is what we use to translate that physical movement into the virtual movement which we control with our game pads. So if you want to go into VR, you want to go into design of virtual reality for gaming or for maintenance or for whatever application, you can create your own virtual reality platform. So we have so many softwares online which you can create your virtual reality platforms. So you have to understand the basic principles of line geometries. So it is very important. I will encourage you all to take more time, learn geometry. You have great professors, great teachers who are very good in this aspect. And at a diploma level, it's more practical for you guys. So you should use that opportunity to learn a lot from them. And if you decide to pursue your degree after the diploma, or you decide to pursue a career after your diploma, you can go deep into a more general application of geometry in terms of design. It could be architectural design, interior design, landscape design, or urban and regional planning, or even geography, whatever you design, or even engineering, or even computer programming. Okay, so I wish you all the best. Thank you so much.
Thank you, Doctor, for the great answer and explanation.
Yes.
To all the students, we have come to the end of our program. Let me end our session with an Arabic proverb. Time is like a sword. If you don't cut it, it cuts you. So for
That's true.
almost 2 hours, we succeed in dominating time with a valuable and beneficial session with Dr. Samuel. We believe that all tips and knowledge shared by our speaker will inspire our interest as a mathematician. Thank you very much, Dr. Samuel, for the
Thank you
remarkable
so much.
and sharing session.
Thank you so much.
Okay,
Thank you so much.
to all the participants, please stay with us for the photo sessions. So I would like to invite all of you to turn on your video, have a group photo.
Also, in case you need the slide, I can send the slide to Dr. Azlina so you all can have it.
Yes, you can share with me and I will share with all the students.
All right. Thank you so much.
Okay, thank you, Doctor. Okay, maybe for all the students, you can turn on your video. Let us wait for a while.
Hello.